Alright, time for another draftphysics.com video presentation. Debatephysics.com. But it's all for naught, really, because the search engines provide zero references. I mean, just zero. So websites are sort of a thing of the past. There's no point in having one anymore. Because you won't be in any way accessible. The page is invisible to the public. So there's just no point in really having one. But anyway, that's a whole other subject, how the human race has failed to do the internet correctly and let it turn into corporate shit. Because they all are gutless, cowardly, wimpy suckers for bullshit. So, in that line, this Dispar retard character, did an experiment. It's a piece of crap. I point out it's a piece of crap. I say, look, it's pretty easy to go find the piece of crap in the experiment, so why don't you do that and be an honest player here somewhere. So no acknowledgement, no attempt to find it, no conversation in the comment section about it, nothing. Just leave the video up, even though it's a steaming piece of shit. Okay, so that's where we are, and they're all astonished like this. The Falwell guy does an experiment, does the measurements completely wrong, gets outed by his own people who tell him, your measurements are probably fucked up. Doesn't care, just couldn't care less. Okay, just deceive you little morons, whatever morons are in the audience. I mean, they're who is the audience anyway? There isn't much of one. I mean, Google owns YouTube. YouTube is just as dysfunctional as Google in terms of searching anything, so clearly there's just no way to be part of the viewable stream of content on YouTube. This is all the invisible internet. Okay. By willful, deliberate strategy of Google. It's just really bad. But anyway, alright, so the experiment was almost forgettable. Alright, so the idea was to hit something and knock it over. Who cares? A milk carton with fluid in it or whatever. The idea is, when's the tip? How much energy do you have to hit it to tip it? And the idea is to hit the object with something with energy, and the basic comparison is let's do the half mass, okay, versus the whole mass at twice the velocity. This would have 2 velocity, and the one mass would have half that velocity, or 1. And these should be equal things, and so you're just trying to find that out. Can you hit things with this? So the idea is to use the pendulum, which isn't a terrible idea, and you just measure the maximum value here at the base, okay, and you get a speed of some kind, and you say, okay, this is the velocity. I measure this as 2v. Okay, now to have 2v, though, the catch is you have an arc that's pretty much twice as much as 1v. Okay, so the 1v arc with the heavy mass, let's just say it's a 2 mass, and we'll make this a 1 mass. Alright, I should just make this whole drawing much bigger. I can't really draw them on top of each other, but basically what's going to happen is the 1 mass is going to swing this arc, okay, and here's its peak velocity, and then the half mass is going to swing this arc. Alright, now it's kind of easy to figure out that these 2 arcs aren't very parallel. Yeah, I could draw them a little better. Alright, something like this. Okay. Alright, so this is the 2 mass arc. Alright, and this is the 1 mass arc. Alright, and you're basically saying that, okay, we can test their velocities here. So he uses the timing gates to test their velocity here. But what he's done is put the thing he's tipping over here. Essentially. Alright, we'll just draw this line a little bit through here, but it's not much through there. So you can sort of see by the time it's reached this point, this velocity for this object has declined substantially. If you just said that the final velocity, even if we forget the rules, of declining velocity, which are, 1, 3. Okay, you're going fast, and then you slow down a lot towards the end. So as you're getting towards the end of your rise, you slow down a lot per unit of distance. So it's lost energy, and it's really losing energy towards the end here. So you could say that this only has 80% of its velocity left. So the velocity it has here is only 80% here. Now this one, obviously, because it has a much larger arc, it's spending a lot less time losing energy here. Okay, so it's lost a lot less, and it might have only lost 40 or 30%, okay, of its velocity. So this, right, and so this velocity was 10, it's only 2 here, okay, and if this velocity was 20, you can do the math, right, 6 or something, 30% of 20, yeah, it shouldn't be that challenging, but I'm having one of those days. It's something like 6. So you're saying that this is this is retained, it still has 14 or 15 of its velocity that started as 20. So it's a huge disproportion in terms of you're comparing one object that's almost stopped moving to an object that's still got half of its velocity, essentially. And so even though this is twice as massive, at this huge decline in its velocity, it's not going to be able to knock the carton over as easy. So the whole thing is just nonsense. It's just, you can't do it this way. All right, you have to figure out a way, okay, to get these heights right. And the simple truth is, I said this before, you could just have an object, and then you just let you move the object this way, and the thing will fall off of it, and you probably get pretty consistent results. So find a way of launching something where you always get the same velocity here, and then you won't have to have your timing gates in the way, and then you can put your carton right there, and then you can see how it works. Okay. Then you can see you'll do a real test of when they have the 2-to-1 velocity. They don't have a 2-to-1 velocity here. Here is not a 2-to-1 velocity. That's the whole point, because these arcs are so substantially different. This one lost so much more energy in this 4 inches than this one lost in 4 inches. The arcs are different. Okay, there. That's all you have to know, right? Come on, you don't have to know anything more than that. These two arcs are of a different length, and 4 inches, if I take a space and cut it out, this one's being affected a lot more than this one's being affected, of course. So it's not that complicated an argument. Alright, and it just demonstrates that you got to do the experiment in a different way to be fair to the experiment, and so you're once again just deceiving people, and apparently you just don't care. And that's being made obvious. Alright. Maybe I'll just leave it at this one subject. I kind of want to talk about spinning things in the universe, because it does kind of defeat the whole relativity argument, right? I mean, it would be a little bit silly for you to think that if I spin this, that the whole universe is spinning. No chance, really. And I have so much relative verification that this is doing the spinning. I mean, everything inside of it saying that, yes, there's relative motion between the little things in here, and it's not out here. Out here isn't doing anything. There's no frames. So ridiculous to argue this stuff over and over. But the problem is we need a better audience. Obviously, the audience couldn't figure out what was wrong with this stupid, couldn't detect something this stupid. The audience couldn't, well, part of the audience did detect it. I mean, frankly, again, his own people told Falwell that he measured wrong, and he just didn't care. It's just that amazing. He didn't care. The fact that he changed the experiment entirely, alright, gave something way more velocity than it was supposed to have. He just didn't care. Stunning, really. That I have to interact with people who don't care that there's a gross error in the experiment. They just don't care. Oh, god damn. So anyway, yeah. So, but without an audience, this is all kind of moot. So, it really is kind of funny that we have this new age, cameras everywhere, all of this stuff, all this technology, all of this way of organizing, and and it's closing what we can see. It's making what we can see small. It's giving us less and less resolution, not more and more resolution. It's essentially pointing everything to the same thing. We're all supposed to just follow the Borgs, the group think thing. All of that is getting stronger, and this technology should be created to make it weaker. There should be more accountability, not less. That's the incredible part. Alright, so till the next time and such. And it's not incredible, I guess, when you start to really interact with human beings and poke at them a little bit, and you can see they're all made out of shit. They're all made out of hypocrisies and duplicities, lies, distortions. They'll pervert anything, they'll distort anything. They just couldn't care less about anything called truth. It isn't a relevant word in their vocabulary. Honor, integrity, these things mean nothing to humans. Generally speaking, you have to find a rare human who thinks those words mean something. Disgusting. I puke in your direction.